Today, together with Christoph Eichler, we are going to present you the working group of the airport room. During the past years, we are working on international solutions in order to connect the BIM and GIS world. And with this presentation, we would like to highlight some basic steps that we found to be important during this process. I will start this presentation with a small introduction about myself. My name is Maya Tryfona. I work as a data engineer at the asset management department of Schiphol Airport. I've been a member of the steering committee of the airport room of buildingSMART since 2017, where I have been involved for the past 2 years with the working group of the airport room. I think on the next slide, I will give the floor to Christoph to introduce himself and to begin with our presentation.
I'm working for the Vienna International Airport in the building department. I'm responsible for research and development there. And I'm also a member of the board in buildingSMART Austria, and I'm responsible for the complete control of the working groups there and for the connection from the national to the international activities. And I'm also senior consultant in an office called ODE, Office for Digital Engineering, also located in Vienna, with the advice to large-scale clients and so on. I'm originally architect. I did this up to 2011, but later on I am starting to work as a consultant or to work for clients in consulting them in BIM projects or later on in the whole control of assets. So I'm also a member of the buildingSMART Airport Room Steering Committee since last year, and I'm a member of the buildingSMART Austria board since 2020. But now to the real important stuff. Our Airport Room Steering Committee and our Airport Room Steering Committee decided to start several working groups. The BIM to GIS working group is one of this. The team here is actually composed from different people. Maya and me, we are one of the European members. There's also Birgitta Schock from Switzerland. We have also Birgitta Foster and Adam Rennick from the US, and we are the core team for the BIM to GIS activities actually. The whole airport room has much more members worldwide, but this group here is focused on the BIM to GIS stuff. Our actually objective here in this group is actually getting a solution for a real working BIM to GIS workflow, or call it actually also BIM to GIS connector, because it seems that we need several software components in this translation process as well. And also to get a solution to declare content in GIS and to transport 3D content in GIS with a semantic. For this reason, we actually are looking for a CPGML solution inside GIS, but I will explain much more later on, and I think Maya will explain much more later on about this. But at the beginning, what's the reason why we want to use GIS actually? As you know, airports actually are small or sometimes medium-sized cities with a lot of facilities and with a lot of technical infrastructure. And airports are in the special role that they have control about all those things in one hand. So that's a huge difference to usual cities, because in usual cities you have different hierarchy systems and you have different responsibilities. Inside airports, everything is in one hand, and airports have much more detailed control about all the activities there. And another thing is airports need to work very efficiently, and they have a huge consumption in energy, and that's usually also a huge or a big cost factor. And for that reason, they are looking to decrease energy consumption and to get good control about all the facilities in their responsible area. And GIS is a very good solution to get control about all those things, because GIS brings us together all the static informations inside a whole area. This means all the building informations, all the infrastructure informations, and so on. But you can combine them with different dynamic informations, for example, sensor informations, values from counters, from measurement devices, and so on. So the GIS is something like a huge dashboard for us in airports to collect all the reasonable informations about your assets. And that's really, really important. And it's getting more and more and more important because airports getting more and more complex because of security reasons, of technology reasons, because of the actually a really huge thing, a whole change of functionality things in airports. You need to implement so much technology that you need something where you can collect all those things together. And as you know, the GIS platform actually has some limits, especially if you want to implement 3D content. But a huge advantage thing about GIS is actually that you can put all those things in inside GIS with a geographic correct relationship, and that's not possible actually with BIM, especially if you have wide or large scale facilities, and airports usually are large scale facilities because you have runways, you have a huge amount of assets all around, parking spaces, railroads, connections, and so on. And if you want to have a real geographic relationship between all those things, you have to use GIS. There is no alternative solution actually for that. So that's actually the reason why we want to use GIS, but there are more reasons for this. Oh, was too fast. Actually, it's also interesting to collect all those informations in GIS platforms because you can implement a lot of different stakeholders in those informations. You can control access rights because you have different roles, you have different security concepts. You can give the public access to some parts of your information, especially if you want to deliver different mobile apps with information. Some members of our airport room did really great pilot projects with this, especially San Francisco. They implement the whole traffic system in their GIS system, so they can deliver Uber applications with the information about incoming flights and the passenger numbers. So they know exactly, okay, there's a plane from Tokyo with 600 people, and they know exactly in 25 minutes they need so much cars to for the passengers if they want to leave the airport, and so on. So this is interesting stuff that you can include your own people, or you can include your own workers or stakeholders, but you can also include external or public stakeholders to your information. And you can control exactly what is public, what is private, and so on. Next thing is that you can visualize your content in many different ways, and you can learn about those content, or you can learn about those visualizations about different, we call it behaviors, because actually you need to understand behaviors of your buildings, of your assets. You need to understand the behaviors of the people living in those assets. Actually, it's a really interesting situation, or interesting is a sad situation. Airport's completely empty, actually. If I'm looking outside from my office, there are a lot of planes, but no passengers. And this situation is very interesting for our building department, because actually we learn how much things in buildings can be turned off without destroying the buildings, because we need to save energy, because there is no need to operate something actually inside the buildings. But if you want to do this, you need to look about the buildings very carefully, and you can't go in all the buildings. We have actually 150 buildings here in the airport, and you can't go to every building all the time. You need sensors, and you need to make measurements all the time to learn what it's actually the behavior of the building. In former times, a year ago, we have 140,000 people a day in the airport, and then we need to understand what's the behavior of the passengers, how much people are in which area at which time, and how much heat they bring inside buildings, and so on. And all those things can visualize inside GIS platforms very easily, because this is actually made for this. This is one thing. And another thing is as well, the whole spatial analysis stuff. In normal environments like in cities, shadow estimation and such things are really interesting. Network analysis stuff is also interesting, but in airports you have another stuff. You have all the things for your flying security control and so on. All those things can only estimate if you have a geographic correct environment, and this can be only done in GIS solutions actually. There are another workflows or another use cases actually, for example, wayfinding inside airports. Remember, for example, in your airport in Frankfurt, wayfinding from different railroad stations to your terminal could be a very good idea, or actually it's already implemented there. I'm not quite sure. So such things can be done also in GIS, and this is actually getting very common in airports to implement stuff like this. But now, what's the vision of our working group? The vision actually is that we need a working connection between BIM and GIS, which can be run from different applications on one side, on the BIM side, because actually we have completely different scenarios. That's the interesting thing about airports. They work worldwide. The setting of an airport is standardized internationally. So the things in Schiphol at Maya's place are in many things exactly the same as here in Vienna, or as in San Francisco at Adams Airport and so on. But the environment from BIM applications and so on is completely different. Here in Austria, we have completely different BIM applications than the people in the US. The only thing which is quite common is that they deliver us information inside this IFC. And on the other hand, in the GIS world, it's exactly the same thing. For example, San Francisco works with a Google solution for GIS. Actually, here in Europe, we have ArcGIS from Esri, or we have QGIS solutions. There are many different solutions. So the only thing which is quite completely the same for all of us is that we need a workable solution from BIM, from IFC to GLS. And this has to be done in best thing could be if this is working bidirectionally, because this, we need also information from the GIS world inside BIM as well. If we make a conception work, or if we want to deliver our external designers or engineers with rudimental information about new places. So that's one thing or one step of our vision. Next step is if we transport information from BIM to GIS, we want to get the whole semantic from the information as you got inside BIM. This means you need a centralized data dictionary, and you need the possibility to declare content in BIM exactly in the same way as you can declare it in GIS. For that reason, we need something to transport information in GIS element-based in a nearly same way as you can do it in BIM. And the solution for this is CDGML. So this is another really important component in our working group here, that we need a good way to declare content in CDGML. So my last slide, if I remember right. Oh, no, this is my last slide. So the overarching meaning of our working group is that we need a connection between a project information model area and an asset information model area. Maybe all of you know this wording here. This is coming from the ISO 19650. This is something like the whole basic document for operating actually assets, and also for scheduling, design and construction. And this setting, which is declared in the ISO 19650 for within project information model for design and construction, and with an asset information model for the operation. This is, in our opinion, actually a really good idea. And in our opinion, BIM is the perfect solution for the project information model. But if you want to work in an asset information model, you need a GIS, as I explained, or as I mentioned before. And if we talk about GIS, we need a city GML implementation, because otherwise we are not able to declare content and to transport precise content from the building inside GIS. Because actually we're working with 2 or 2.5D content in GIS, but we want to get more informations in GIS to connect also other informations with the GIS platform. So the GIS solution should, in our opinion, should be the central data hub in an asset information model. And we want to connect other applications to this central data hub to work with this information later on. So we have EPR software like SAP, Unifier, and so on. And all those business software for the operational business stuff in airports has to connect also with this unique data hub. Otherwise, you have redundant data in an airport, and this is really, really dangerous. And this is something we actually don't want to have. So for that reason, we are completely focused on the connection between project information model and asset information model, with the possibility to declare content in the same way. This is actually the focus of our work. But now Maya explained this much more detailed to you in the next slides. So I hand over again the control to you, Maya.
Yes. Apparently the escape button was working, but the right button is not.
Or should I? Maybe you can only, maybe we make it like this. You say to me, next slide, and I press the button for you.
So what we have done so far, we tried to break down the process into steps and identify the challenges per step. In this slide, you can see the core of the process that we used, where we are highlighting the key steps to achieve this connection, at least from our perspective. In the next slides, we will go through these steps, highlighting the parts of the process that complicated things for us. In the next slide, Christoph?
Oh, yeah, sorry.
Thank you. In this slide here, we are not showing the most up-to-date status between these 2 software vendors, but this slide is used here to show you that different software vendors have a different focus area, and they are supporting different parts of the IFC schema. And this is very, very important to know, especially at the beginning of the process, in case you need to exchange files between different software. In the next one, we want to highlight that we need clear agreements which derive from the business needs, like the different stakeholders, the safety and security, space management, and others. In order to be able to speak the same language, we need high quality models, which are modeled according to the desired requirements. So the validations of the models are very important on every stage of a project, in order to ensure the desirable data quality of the model before proceeding into further analysis. In the next slide, we want to show that, especially in big projects, auditing is essential and can result in a high quality end result if it is happening incrementally while a project is progressing. Moving forward, there is a confusion during the export settings, which we want to highlight here. So when you want to export a file to an IFC format, when you're a practitioner, you must choose from many options, many export setting choices, which can affect the computations that the GIS specialist will need to make in the next phase. On which choices you need to pay attention? Well, in our opinion, when we want to speak about GIS, the project origin and the IFC site elevation play a very important role, and they are affecting the calculations for the positioning of the model in space. In the next one, when joining data from multiple sources, or while transferring data from BIM to GIS environment, the units need to be taken into consideration. So you can see how crucial the difference can be between millimeters and meters by comparing, for example, in this picture, the location of the blue wall and the windows of our example building. So this is also a very important step that you need to take into consideration. Moving forward in the next slides, we will speak a little bit about the georeferencing step. Unfortunately, we will not be able to cover every detail in this presentation, but we will highlight some key points. So during the design, the files are placed in a local coordinate system. Within this local system, it is interesting to understand the differences of the absolute and relative placements of the objects with each other and with the project base point. Therefore, good guidelines are necessary in this step to ensure that all parties are on the same page regarding the local coordinate system of the project. So in the next one, to combine basically BIM with geospatial data, and transformation needs to be done from the local coordinate system to the map projection system that is used in your country. But then how can you do this transformation? Well, to the left, we show here an example of the grid that is used for the local coordinate system of Schiphol Airport in the Netherlands, where the 0 point is in one of the piers of the airport. To the right, you can see the national map projection system, which is used in the Netherlands, the RDNU, where you see that the 0 point is somewhere in Paris. So in the next slide, to make the previous transformation in large sites like airports, the curvature of the Earth could play an important role. So, for example, airports like Schiphol have a very large site, more than 3 kilometers. Therefore, we really need to make the transformation, but taking into consideration few more parameters. And a few years ago, we explored this guide, which includes more details and explanation on the issues that can occur in large sites. Nowadays, there is a new version of this guide, which is called User Guide for Georeferencing in IFC, I think. And I think that personally, I truly believe that this guide helps a lot on the establishment of a common spatial reference at the beginning of a project. An example here is in this picture to the right, where you can see how you can store the needed parameters in the different IFC versions. So with these parameters, you can, for example, use them. The GIS specialist can use them in order to know what exactly he needs to do by transforming this file from the local coordinate system to the correct map projection system. In the next slide, another part of the IFC standard, which can be also useful for a GIS specialist during the georeferencing of a model, is the information that can be stored in the IFC site. At the bottom of this slide, you can see an example of such a line in an IFC file, where in the WGS 84 projection, the latitude, the longitude, and the height above the sea level of the survey point of your project can be stored. And with this in place, the georeferencing of the model is way more straightforward. And next, after covering the export settings, the units, and the georeferencing part, we are moving through our steps to the attributes. So for some airport-specific asset types, which are not covered in the IFC standard yet, like the automated border control systems, we are using the customization which is available from the IFC standard, like the IFC building proxy element entity, the custom property sets, custom properties, and the user-defined enumeration types. Here, we want to show you not only the flexibility that you have with the IFC standard on customization, but also the attention that you must pay to ensure that you are getting all the data from an IFC file. In the next slide, you can see an example of an IFC slab, where the user-defined enumeration type has been used. And this can be very beneficial into the count of your building elements that you need for example, for a specific business case. Next, we want to address a big subject, which is the topology. So the topological relationships are very important for a successful spatial analysis. And here you can see different types of element connections, where in the next slide, we want to highlight that with proper editing in BIM, you can result in clean topological relationships, which can save time and of course make the life of a GIS specialist much easier. In the following slide, the geometrical requirements between BIM and GIS vary, and it is worth noticing the geometrical differences between the two standards, the IFC and the CTGML. As Christoph mentioned before, CTGML is very useful, and we really need to understand the differences, which can be spotted on the windows, the doors, and the walls, as well as on other objects. In the next slide, we should understand that the geometrical requirements depend on the use case. What do we mean by that? On some business cases, we might need to represent a door with all the geometrical details, while in other cases, only as a line, or in other cases, only as a point on a map. So the geometrical representation can be simplified depending on the needs. So next, stepping back a little bit, if you look at the common elements in a BIM environment that are relevant to GIS, it is fairly simple. We mostly talk about doors, walls, and rooms, which are relevant to all stakeholders. So everyone needs to know where their equipment and their building are located. So walls, doors, and rooms give us the framework to do that effectively. On top of that, for airports, since we're also part of the airport room, there are also additional elements which are unique and common across airports, like as I mentioned also before, like for example the baggage carousels and others. This can all be combined to what we call model view definition. So a model view definition is a subset of your model which tends to serve specific business needs. Airports have common business needs for which the needed data can be extracted from the BIM environment as an airport model view definition for specifically the airports. That is the baseline. We start to look at all the stakeholders individually. They all have domain-specific needs, which can be documented in smaller model view definitions for each specific stakeholder. So in the next slide, if we do this, we can basically layer the airport model view definition and the smaller data sets from the stakeholders very effectively, and in this way prevent duplication of information or duplication of work, which often occurs in a siloed organization. Here you can see some possible subsets of the airport MVD, model view definition, like the wayfinding MVD, the fire life safety MVD, and the security MVD. So in the next one, if we do this, we basically achieve higher consistency and better focus on what is really needed. The selective exchange is also building resilience in an organization, because a smaller data set is easier to maintain, of course, and your stakeholders can be clearly in control of what they need and become also more aware on how to collaborate better with the other stakeholders within the organization and outside the organization. So to dive a little bit deeper into some technical details, let's have a look at the next slide at the floor plans, which are basically 2D representations that we need. We talked previously about 3D conversions, but in many practical use cases, it is enough to look at the floor plans as a 2D background. After all, we just want to make sure that we know where we are in the building and on the campus. So the doors are usually very important to most of the stakeholders. For example, wayfinding, as Christoph mentioned before, and security are very interesting in the location and in some of the parameters of the doors of their buildings. And rooms are important to be properly transferred from a technical perspective, because rooms in GIS are used for spatial analysis and calculations. So in the next slide, when it comes to transferring information, we found through our work that, at least for now, not all formats are suitable for all the circumstances. So to transfer the data, the floor plans, in our experience, are best to be transferred in DWG files. Doors can be converted into point features in GIS, because after all, we need to make sure that we know exactly where these doors are. And we can add data in a tabular form to these point features. And for rooms, we can convert them easier in IFC format. The reason for choosing this is for the so-called donut situation, where there are holes within rooms, and that is hard to translate from the technical perspective if you have two polygons that are inside each other. So with IFC, this can be handled fairly quickly and easily. In the next one, when we look in organizations, of course, many organizations look at the 3D conversions, but in reality, many organizations are also good with just a simplified, focused way of looking at the information in GIS. But the bottom line is that everybody can have access to GIS and benefit from using GIS. So for airports, there are typically more robust implementations of GIS because of regulations and because of the precision that is needed. But there are also free software solutions. Some are listed in this slide, like here and Google, so that smaller organizations, organizations who do not necessarily have a dedicated group, can benefit also from what GIS can offer to us. And in the next slide, and my last one, I'm going back to our airport room. We have the continuation of this work outlined. On the next steps of our work, we will be diving a little bit into the connection of IFC and CityGML. And now we can talk about IFC-JSON and CityJSON, which is exciting to us because these file format renderings are going to create much higher speed during translation. We are looking for more collaboration, of course, with airports, and because we are already experiencing and benefiting from the practical accelerator nature of this collaboration. And we will develop more business cases in the future for that reason. We will delve a little bit deeper into the topological issues on how can we represent them or clearly manage them in an IFC format. And here is also probably worth mentioning that we are closely following the developments of software-specific solutions as well. And with the next slide, I want to thank you very much for your attention.